Hello again, Mr. Eves with you here. And now we're going to be working through some IXL problems involving classifying numbers as rational or irrational. Also looking at whether they are whole numbers, integers, whole numbers or integers, as well as being rational or irrational. Remember, all of these numbers that we are dealing with are classified as real numbers, so we're just going to take that for granted. All right, so I'm going to start in the 7th grade math skill H5, classify numbers using a diagram. And once again, just as a reminder, hopefully you got to watch my other videos where I worked through some problems and explained this whole relationship. If a number is a whole number, that automatically makes it an integer. And if it's an integer, that automatically makes it rational. And over here in their own category will be those irrational numbers, and they don't overlap at all. All right, so it says, which of the following is an integer but not a whole number? Remember, whole numbers cannot be negative. Whole numbers start at 0 and go up by 1. They're like counting numbers that you can count on your fingers, except they add 0. So which of the following is an integer but not a whole number? All right, so 53 is a whole number, 165 is a whole number, 33.15 would not be a whole number because it does not have, because it has a decimal. So therefore 33.15 is neither an integer or a whole number. Negative 122, remember integers are whole numbers and they're opposites. So negative 122, because if you took the negative away it would be a whole number, but with the negative it makes it an integer, but not a whole number. All right, let's take a look at the next one. Which of the following is a whole number? All right, whole numbers can't be negative. So right off the bat, that knocks out the first 3. All right, these two would be integers. This one would be a rational number. So 89 is the one we're looking for as a whole number. All right, which of the following is rational but not an integer? All right, so again, rational numbers is anything that can be written as a fraction. Integers cannot be fractions or decimals. Okay, so all of these are rational numbers. 18 and 84 are whole numbers and integers. Negative 63 is an integer, but only 9 2/5 is the rational number, but not any of these others. Okay. All right, what about this next one? Which of the following is both a rational number and a whole number? All right, so this one right here is definitely not a whole number, right? This one right here, not a whole number. Whole numbers cannot be negative, so 185 is the only one that is a whole number. It's also an integer. It's also a rational number. See how it's in the smallest circle here? There you go. All right, I'm going to skip up to the next level, see what they got for us there. Which of the following are rational numbers? Which of the following are in this big circle? Well, negative 174 is an integer, and that's a rational number. Negative 14.1, that is a rational number. It's not an integer. It's not a whole number. 168, that's a whole number. It's also an integer. It's also a rational number. And same with 7. 7 is a whole number, an integer, and a rational number. It's all of those. All right, which of the following are integers? Okay, 74 right here. Is 74 an integer? Yes, it's a whole number, so it's also an integer. Same thing with 124. Whole numbers are automatically integers. Here's negative 148. That is an integer. What about negative 2 1/8? Is that an integer? It's not. Okay. Remember, sometimes students think all negative numbers are integers. Not so. Integers are whole numbers and their opposites. No fractions, no decimals. All right. Okay, let's do one more. Which of the following are integers? Again, 87 right there is an integer. 24 is an integer. They're whole numbers, which makes them integers. Negative 165 is an integer. Negative 2/9, no way, Jose, because it's a fraction and integers cannot be fractions. All right. Okay, so I'm going to stop there on that one, and I'm going to skip over to the next one. We're now on 8th grade, skill D5, rational and irrational numbers. So just a reminder, rational number is anything that can be written as a fraction. That includes decimals that either end or they repeat a pattern. Irrational numbers are decimals that go on forever and ever and ever and don't repeat a pattern. So is 9/10 irrational? No, it's rational because it is a fraction. All right? 1.853, it's a decimal, but it ends. So is it irrational? No, it's rational. All right? 7.866, again, once that decimal ends, it is rational, okay? It's not irrational. Wait, what did I say? Oh, I should have said no. I don't know why I said yes. Sorry, guys. All right, is 8/5 rational? Yes, it's a fraction. Therefore, it is rational. Is 0 a rational number? Yes, 0 is a rational number. 0 is a whole number. 0 is an integer. 0 is rational. All right? Is square root of 8 a rational number? Okay. Now here, and this is what's going to be in the next section as well, is where we have to pause and think. Is 8 a perfect square? All right. So we have the square root of 9, which is 3, right? And we have the square root of 4, which is 2. And in between those is the square root of 8. It is not a perfect square. But just in case you weren't sure, you can go to your handy-dandy calculator and you can find the square root of 8. And you will see that it is a long decimal. Now, it doesn't go on forever in your calculator, but it would, okay? So is it a rational number? No, because 8 is not a perfect square. All right? Is 3/9 a rational number? Anything that can be written as a fraction is rational. All right, let's skip up to the next level, see what they got for us, okay? Is -6 square root of 16 a rational number? Well, the square root of 16 is 4, right? So negative square root of 16 would be -4. And guess what that is? That is an integer. Therefore, it is rational. Yes, it is. All right. Is 47/5 rational? Is it a fraction? Yes. That makes it automatically rational. All right, what do they got for us at the next level? Which of the following is an irrational number? Well, 0 is a whole number. Square root of 9 is 3. 47 is a whole number. Pi. That is like your poster child for irrational numbers. Pi is irrational. Goes on forever and ever. All right. Excuse me, which of the following is rational? All right, well, 53, 71, and 48, none of those are perfect squares, right? None of those are perfect squares. The closest perfect square to 53 would be what? 49. The closest perfect square to 71, you have 64, and then you have 81, right? 49, and this would be 64 if I put what they're between. Right? Square root of 48 is between the square root of 36 and the square root of 49. So none of these are rational. Now here's a decimal. It goes on forever, but it repeats, and you're allowed to repeat to be rational. All right, which of the following is irrational? All right, fraction and fraction, automatically rational. Whole number, automatically rational. Again, the square root of 85. Let's see, that's the square root between 81 and 100. Perfect square, not perfect square, irrational. All right? Okay, how about one more level? See what they got for us at the challenge zone. Which of the following are irrational numbers? Well, 0 is whole number. That is rational. 25, perfect square. Square root of 25 is 5. 49, perfect square. Square root of 49 is 7. There's our 46, which is between the square root of 36, which is a perfect square, and the square root of 49. It's in between them. So therefore, it is irrational. All right. Last one. Which ones are rational? Again, if it can be written as a fraction, it is rational. If it repeats, it goes on forever, but it repeats, it is rational. All right? Negative 42 is an integer. It's rational. They are all rational. Wow. Okay, that's all I'm going to do there. Look at, I got us all the way up to 92. Last one, and we've kind of already done this already. Now we're just looking specifically at square roots. Okay, is it a rational number? Well, square root is 7. Let's see. It's between the square root of 4, which is 2, and the square root of 9, which is 3. Okay, it's not a perfect square. Again, if you wanted to put it in your calculator, if you put in the square root of 7, you can see you get a long list of decimals. All right, that is your indicator that it is irrational. So the answer is no. All right, let's skip up to the next level. What do they have? Square root of 54. Is it irrational? Again, square root of 49 is 7. Square root of 54 would be here. Square root of 64 is 8. So it's in between 7 and 8. All right, it's going to be irrational. So is it irrational? Yes, it's irrational. All right, skip up to the next level. What do we have? Which of the following is rational? Well, which is a perfect square? The square root of 0 is a perfect square. Is 26 a perfect square? No. 42 a perfect square? No. 80 a perfect square? No. Again, 26 is between 25 and 36. 42 is between 36 and 49, and 80 is between 81 and 64. Okay, so none of these are rational. They are all irrational. All right, and now to the challenge zone. Which of the following are irrational? All right, well, the square root of 81 is 9. That is rational. Square root of 16 is 4. That is rational. Square root of 29 is between the square root of 25 and 36. Square root of 99 is just a hair below the square root of 100 and above the square root of 81. So these two are perfect squares, so they are rational. These two are irrational. Irrational, irrational. Gotcha. All right, well, hopefully that's enough for you to understand better now rational and irrational numbers, as well as integers and whole numbers. And I threw them in. They're not in the book or in IXL, but they're counting numbers. All right, have a great day. I'll see you next time, guys. Bye.